Hello everyone, I'm Sagar Dhotare. So today we will discuss the end part of the rolling contact bearings. So previously we have discussed different classification of the bearing, then different type of loads, definitions of the loads, then life relation, static and dynamic capacities, how we can find out. We have seen Strabag's equation, then various formulas we have seen in previous two lectures. So, so in this final lecture, we will discuss about the mountings, then materials and the lubrication mechanism and the failure mode of the bearings. Okay, so we'll discuss one by one. So before starting, I request all of you, please subscribe my channel, so and click on bell icon, so whenever I upload any video, you will get directly to you. Okay, or the notification you will directly get it. Okay, so the mounting, what is mean by mounting of the bearings? It is nothing but an installation of bearing on the shaft in housing. Okay, so there are two types of mounting arrangement are shown in the figure. So first one is a fix. So in a fix, both bearings are fixed. It's shown in figure number 1. The inner race of the bearings are backed up by cover plate, which are bolted with to the housing as shown in figure. The adjustable spacer are used to permit the axial free play of the shaft to be adjusted to the desired amount, which is shown in figure. Okay, you can see the adjustable spacer which is shown over here. With the help of this spacer, you can adjust the spacings. Okay, so in this both ends are fixed, and because of that it should not move from one it should not move from anywhere, and because of both ends are fixed, the left side bearing takes the thrust direction towards the left and right side bearing takes the thrust direction towards the right. So it directly equalize the thrust load also, and it having a disadvantage that if the distance between bearings is large, the temperature rise during the operation may be expand the shaft enough, which can be induced the several axle loads in the bearings. So that this one is a huge disadvantage of the fixed bearing, as both ends are fixed, so heat generation is high. So that's why we needed a proper cooling arrangement should be there. Second one, the fix and floating. In fix and floating arrangement, one end is a fix and other end is a kept floating. The inner rays are backed up against the shaft shoulder and are held in a position by locking nut threaded which is on the shaft. Okay, you can look the difference over here. Okay, so here both, this one is a locked one, here it is shown, and this area this one is a floating one. Okay, so locked one, it is locked by with the help of shoulder, which is directly connected on the shoulder, and in the other end the threaded nut is provided, so it can adjust the spacing. The outer race of the left side bearing is held in a position by cover plate, and outer race of the right side bearing floats the housing. Okay, so both as shown in figure, it is directly left side is constantly fixed and right side is floating. This type of mounting The left side bearing takes a thrust in a both direction. So these are the two basic mountings or installation methods, but there are some few alternate methods are present. So we'll discuss one by one. So first one, the using of washer and lock nut. In this arrangement, the bearing is back up against the shaft shoulder and held in a position by using washer and lock nut. You can see in the diagram, it is here the washer and lock nut are placed, and it held to the bearing at a particular proper position. In the second case, the washer lock nut with a spacer arrangement is provided. In this arrangement, the spacer holds the proper position, holds against the helps against the spacer, and it held the position of washer and lock nut, which is shown in figure. A small variation is having in between these two diagrams, otherwise remaining dimensions are same. So in look at this position they don't provided any kind of spacer, so here it provides that spacer. Okay, so against that spacer, the position of the bearing is properly shown. Then next slide. Third one is a snap ring. Okay, so with the help of after the spacer in this arrangement, rather than using a lock nut, they have here we are using a circlip or a snap ring. Okay, which is filled or which can be hold the position of the ring. Now look at here. In this position the spacer is provided, and at this position the circlip or the snap ring generally used. Fourth one, the flat fastened with the screws. A flat plate which is fastened with the screws when bearing is at the end condition. Okay, so this kind of a flat plate is, or we can say cover plate. Okay, so which directly connected, and using the fasteners, here the fasteners are shown. So using these fasteners we can apply the pressure and hold the position. Next one, the adapter sleeve. Now if you look at the if you compare the previous one and this one, you can find this sleeve is normally provided over here, and with the help of washer and lock nut you can hold the proper position. Okay, so these kind of bearings are normally used for angular one. So that angular as adapter which have a small taper is provided on the shaft, and the bearing is pressed fitted on this adapter sleeve. Because of the taper on the adapter, the sleeve, there is a possibility of displacement of inner race. That is a disadvantage of this arrangement, and it moves to the rightward direction. The displacement is restricted by means of washer and lock nut. So whenever the steps are there is no the steps are not provided, and directly we have to mounting or install the bearing, at that condition you can use such type of arrangement. Now next point is preloadings of the bearing. Why preloading is very important? Because to maintain or to um, function properly, the preloading of bearings or proper preloading of the bearing is very important. There are few reasons or purpose behind this. First one, to remove the internal clearance usually founded in a bearings. Second one, to improve the positional accuracy of the shaft. Third one, to decreases the shaft slope at bearing. And last one, to increase the fatigue life of the bearing. If the preloaded bearings are there, then these kind of objectives we have. Otherwise, they can fail with they have reduced their fatigue life. The slope can be occurred with the shaft, inaccuracy in the shaft, positional inaccuracy in the shaft, and maybe the internal clearance will be increased, and that's why they can lose their position. Okay, so there are two methods. First one, the axial preloading of the ball bearing and taper bearing. So it can be developed by either retaining devices or the outer race like a cover plate or lock nut. The second method is radial preloading of the cylindrical roller bearing. It can be developed by either mounting the bearing on a taper sleeve to extend it to the inner race or using the interference feet at the outer race. So out of this, you can use appropriate preloading method. Now next is very important task, that is lubrication. Yes, the purpose of lubrication, basic purpose is to reduce the friction and wear, then dissipate the frictional heat, to protect highly finished the surface from corrosion, and to obstruct the entry of foreign matters like dust, dirt, water particles from outside to bearing. So these are the basic function or purpose or objective of the lubrication system. Now, what are the basic factors we should consider while selecting the proper lubrication system? So first one is operating temperature, second one is operating speed, third one is a bearing load, and fourth one is a lubrication system. If the operating temperature is below 100 degree, grease is very suitable lubricant for lubrication, whereas if the temperature is above 100 degrees centigrade, then we are use oil as a lubricant. About the operating speed, if the operating speed is low, grease is suitable, whereas the operating speed is high, the lubrication oil is suitable. As the speed increases, the friction increases and temperature get increases. So that's why for low speed we are using grease as a lubricant, and for high speed we are using oil as a lubricant. About the bearing load, the grease is suitable for low and moderate loads, whereas the lubricant oil is suitable for heavy duty loads. Lubrication system, if there is a central lubrication system where which is required for lubrication of other elements, the same lubrication oil you can use for bearing also. So it doesn't require a special lubrication system. You can use a central lubrication system for the lubrication of the bearings. Next one, the basic classification of lubricants. So generally there are four types, that is mineral lubricants, synthetic lubricants, vegetable and animal lubricants. In mineral there are fluid, semi-fluid, and or you can say solid, semi-solid and liquid. Okay, in liquid, or you can say oil, the paraffinic oil, naphthalene oil, aromatic oil. There are three types. In a semi-solid, we know that the grease is very suitable material. About the solid lubricants, the graphite is the main one. Then PTEF, then tungsten, then boron nitride, and molybdenum disulfide. So these are the basic solid lubricants which are preferred in the uh, lubrication. Then synthetic we have four types, that is a polyphenols, then polyglycerins, then ester oil and silicones. So out of that you can based on the application you need to select a proper lubricant. Again, based on the application, the lubricants are engine oil, gear oil, hydraulic oil, cutting fluid, wheel lubricants, compressive oils, quenching and heat transfer oil, rust protection oil, transfer oil, turbine oil, chain lubrication, wire rope lubrication. Based on the additives, there are 10 types: extreme pressure, anti-wear, friction modifier, corrosion inhibitors, antioxidants, then dispersions, then detergent, then component, then anti-foaming agent, and pour point depressants. Now, what are the basic properties of good lubricant? So there are few properties I have mentioned here. First one, it should have a high boiling point and low freezing point, because in order to stay in liquid within a wide range of temperature, this property is very essential. Second one, a high viscosity index. If the temperature increases, the viscosity index reduces. So that's why it should have a high viscosity index, so it can withstand with the higher temperature. Thermal stability, yes, it is necessary. Hydraulic stability, if the it cannot flow through the proper channels, so they cannot be able to lubricate the whole system. So that's why the hydraulic stability is also very important. Then demulcibility. Okay, next one, the corrosion prevention and a high resistance to the oxidation. So these are the basic properties the lubricant should have. Next one, we use only two lubricants. First one is a grease, that is a semi-solid, and second one is a oil. So we'll discuss one by one. When we are choosing the grease, the grease is normally chosen for several applications by considering the operating condition. So the properties of grease should be, it should require the oil viscosity at the temperature of bearing, the grade of operating temperature, then soap base, which is best for the application, and applicable of extreme pressure additives. So these are some properties we should have to consider in a priority while selecting the type of grease. Advantages of grease: the oil lubrication required proper sealing to retain the lubrication, but in this type of grease we doesn't require any kind of seals. Second one, it can operate very long period without attention. We should not provide any special attention for checking that the grease is moving from the bearing. So that's why we normally apply the grease inside the bearing, which is shown in figure. Third one, it relatively more clean than the oil lubrication. Yes, oil can be flow from anywhere, any direction, if it reduces its viscosity index. Okay, so it may be where uncleaned, and it can increase the dirt and all the things. So that's why grease is more preferable in that condition. But disadvantages of grease are it is not effective in carrying the frictional heat. At the at, in that condition where the temperature is playing an important role, that is it, if the temperature is high, we should not use, or we never use a grease as a lubricant. It's not effective in flushing out the worn out particles. Yes, it's a biggest disadvantage of grease, because grease will not move from its position. So whatever the worn particles or dirt may be trapped in between that bearings and balls, so it cannot flush out. It always keeping with them. So these are the lubrication grades, where grade levels and the operating temperatures also shown over here. And based on the thickness base, thickened base, the specific advantages, so that you can select for a different application some main advantages of the some specific additives as tabled over here. So grade number 1 and 0 to 1 are relatively soft and are typically used for low operating temperature. Grade number 2, 3, 4 are used for high grade temperature. Grade number 3 are usually used in a vertical application to prevent all greases from settling at the bottom of the bearing. Okay, so basic base compounds are calcium, sodium, lithium, and bentonium clay, and synthetic. So each have their own advantage. So based on this advantage, you can select proper these kind of based thickened grease. Next one, that is oil lubrication. Yes, when selecting the most appropriate oil lubrication method for a bearing arrangement, the following application requirement should be considered. So first one, the quantity and viscosity of the oil. Second one, speed and hydrodynamic frictional losses. And third one, the permissible bearing temperature. So these are the basic properties we should have to consider while selecting any grade of the oil. Advantage over the grease lubrication: it is more effective and it can carry the frictional heat, because it can we can rotate the oil, or it can flow. That's why it can flow out or carry out the frictional heat. Also, it can flush out the foreign particles as well as worn out particles, and that's why the wear of the component, because of it can be trapped in between two connecting points, so it increases the fatigue life of the bearing. Disadvantage of lubricant. Disadvantage of oil lubricant, sorry, I have wrongly noted over there. So what is the disadvantage? Oil lubrication need a continuous attention. We need to check whether the seal is properly closed or not, if oil level is going to down or not, because as the temperature increases because of heat, the level of oil get reduced, because it can be it get reduced. Okay, so the level of oil we should have to maintain. The failure of oil supply can be cause a local heating and expansion, which may lead to early bearing failure. So as I discussed previous same first point also, if the continuous lubrication is not provided, then the temperature get suddenly increased, and because of that, there is a possibility of expansion. Okay, now next and very important part, that is the bearing materials. So whenever you are choosing the bearing material, some characteristics we need to uh, check. So first one, the corrosive resistance. Second, season resistance. That it means that it can withstand with the high temperature. Fatigue resistance. It can withstand with the high cyclic load. Then embeddability. Then comfortability. Then porosity, frictional coefficient, thermal expansion coefficient, thermal conductivity, comprehensive, compressive strength and cost. Normally the load applied is radial load mostly, so the compressive stresses strength should be high. Thermal conductivity and thermal expansion and friction coefficient. So it, as the heat generated, if the thermal conductivity is high, thermal expansion should be low. If thermal conductivity is high, it can easily transfer heat from material to oil or to the other mechanism. And most important thing is cost should be low. So these are the best metallic materials which are preferable for bearing, that we have mentioned in a metallic segment and non-metallic segment. So metallic segment, chrome steel SEA 52100, stainless steel AISI 440C, then bivet, which is more used, then in the bivet that you can use tin based or lead based, bronze, copper lead alloys, cast iron alloy, aluminum alloys, and silver. Whether in a metallic, non-metallic materials, we can use nylon, then phenolic materials, then nitrile rubber, and Teflon. Now, last and most important part of the uh, any theory is modes of failure. What are the different modes of failure? So if you have any idea about the modes of failure, you can increase the reliability, or you can increase the life of bearing to avoid that failure conditions. Okay, so in a normal books you can might be found 5 to 6 modes of failure. Those are the fracture, pitting, scoring, abrasive wear, and corrosive wear. But by using some research paper, I found that the modes of failures are more, and I have characterized and I have set the priority based on the severeness. Okay, so we have mentioned 12 different type of modes of failure. We will discuss one by one. First one is a flicking or pitting. So the flicking on pitting, in a first diagram you can see the flicking of the inner ring of the deep groove ball bearing. So the flicking is the phenomena in which the bearing surface turns scaly and peels off due to the contact load repeatedly received on the raceway and rolling surface during the rotation. And there is a basic second phenomena which one is a pitting. Pitting is the phenomena in which small holes near about the diameter of 0.1 mm in a depth also are generated in the raceway surface by rolling fatigue, and the causes or reason of the flicking is during operation or bearing internal clearance becomes narrow than the specified. Then second one is a bearing ring is mounted in inclined or mistakenly it is not properly aligned. Then flaw is created during the mounting of the mounting, so it can be need to clean properly while mounting. And inaccurate shape of shaft or housing, because of such kind of failures are normally occur. Next one, Wear and fretting. So the wear caused mainly by sliding abrasive particle inducing the roller end surface and the rib cage pocket surface cage and the guide surface of the bearing. The wear due to contamination by foreign matter and corrosion occurs not only to the sliding surface but also with the rolling surface. It can be occur. Then fretting is the phenomena which can occur when slight sliding is repeatedly causes on the contact surface. On the fretting surface, the fretting corrosion should be occur generally because of the rusting, and it could be in the form of powder. You can see in the figure, it is shown over there. So basic causes are wear and fretting. Wear cause is basically the wear can occur by improper lubrication. So or you can there is a amount of lubricant might be short, or because of the foreign particles or contamination of foreign particles. So because of that only wear can be occur. Then fretting is occurred because of the vibration load or vibrating load, and only because of vibrating load or vibration. Because of vibration, the slight repetitive loads are uh, continuously hampering over the contact surface. Next step, the cracks and chips. The cracks include slight cracks, splitting, and fracture. So initially crack propagation can be occur, and that in it convert into the slight crack, splitting, and final output is a fracture. So figure number 1, 2, and 3, you can look at the proper appropriate the failure of roller due to the crack. Chipping are the type of failure occur at the certain part of the bearing rib or a corner of a roller. If it is not properly mounted or properly aligned, because of that it can be occur, or mismounting or misalignment is there, it can be the chips can be occur. The cracks can be occur because of heavy load, then excessive internal stresses, then excessive interface at fitting or on the shaft and housing, and it because of also improper shape. Okay, so because of these are the reason, so that's why this can be happen. Then the failure of bearing, that is a drilling and the nicks. So bringing is a depression creates on the part of the raceway surface which comes in contact with the rolling element, and it is due to the plastic deformation. It is also small depression on the rolling surface caused by the contamination by solid foreign particles. The figure number 2, you can properly seen the brenneling failure or the effect of brenneling. The next are the flu caused by direct impact received when the bearing are hitting by hammer on the solid tool. So these are the impressions which is mentioned, or you can say because of improper hammering or improper pressure apply, this can be occurred. Now next one is the scratches and scuffing. Figure number 1, 2, you can see 1, 2, and 3, you can properly see in the scratches, and 4, 5, you can find out the scuffing. So the scratches is the relatively shown flow caused by the sliding contact. and the scuffing is the flows caused by the high pressure contact pressure and heat on the rolling surface. In generally, more serious are scratches because it can be possibility based on the scratches. It might be go for final fatigue failure. Okay, so the causes of the flue or scratches are or scuffing are the flue can be generated because of careless handling and mounting of the bearings. Then scuffing as can be occurred because of the improper lubrication in contact surface, excessive preloading pressure, then because of the foreign particle and abnormal axial load. Scratches are occurred because of improper rotation of the rotating element, as usual the improper lubrication, and because of the foreign particles which can be uh, inside the bearing. Sixth number, that is a rust and corrosion. The rust of the film or rust can be occurred because of the oxidation, then the hydroxide or the carbonate particles, which can be a chemical reaction. Okay, so that's why the rust is occur. You can see figure number 1, 2, 3. So here it is clearly shown the rusting. And about the corrosion, corrosion is a phenomena of oxidation occur on the surface and is produced by the chemical action with the acid or alkaline particles. So basic reasons, when the equipment is stopped and it has a temperature decreases to the low dew point and the humidity in the housing turns into the drop of water. The water drops often the containment of the lubricant, and as a result the rust is generated on the bearing surface. About the corrosion, when the sulfur or chloronite compound come into contact with the lubricant additives, the under high temperature the corrosion can be occur. The next one, the seventh one is the piercing and discoloration. So piercing is the condition of the rolling surface where the small depression are created entirely as a result of many foreign matters being caught in between the parts. You can see, look at the pictures where it is properly shown. Rolling surface scuffing from the pier skin appears dim and is rough in a texture. In the worst case, the surface is discolored by heat. So discolor is the phenomena in which the bearing surface is discolored by staining or heat generation during the operation. You can look at the outermost area where the contact is occurred. In that position you can find out the discolor failure. The causes are for pier skin. The main cause is because of foreign particles and the lack of lubrication. And discolorize similarly here is also some substance can be removed by scrubbing or wiping with the solvent, and because of that some chemical reaction can be occurred, and because of that the lubricant and other adhesives are chemically reacted, and that's why the discolorization can be occurred. Ninth one is creep. Creep is a phenomena during the operation of the bearing ring relative to the shaft of housing. So because of creep, the failure may be occur, and the interface when the creep is occur, when the interface is too small in relative to the heat or load generation during the operation. So because of that, the creep could be occurred because of the area should be lesser than which is required. Next one, the electric pitting. It is a basic phenomena in which the bearing surface is partially metal by spark generation when the electric current enters in the bearing and passes through an extremely thin oil film at the ending at the rolling contact point. The electrical pitting can be classified into pitting or rigid marks, which the rolling contact surface propagates depression like crackets, craters can be observed when the pitting is magnified, indicating that the surface has been melted by spark. The reason of this kind of failure, the bearing surface is partially metal and by electric current passing through the bearing, only because of this it can be this kind of failure can be occurred. You can look at the figures, you can understood the phenomena. Now 11th, that is a scissor. It's a very common phenomena, or you can say this type of failure are normally commonly it occurs. Although scuffing and simmering can be categorized as a scissor, scuffing is generally regarded as a more serious type of failure. The scissor described in this type of segment or section in the kind uh, is the kind in which the bearing parts are melted and adhere to one another due to the abnormal heat, or the rolling surface become rough. As a result, the bearing can be no longer rotate. Once the scissor occurs, the bearing cannot be used again because it loses its quality. Okay, the reason behind the scissor result from the abnormal heat generated by improper lubrication, excessive preloading, or improper contact of a rolling element with the raceway surface, which cannot be compensated for by the cooling method or lubricating employed in the bearing. So proper lubrication can be reduces the scissor failure. Last one is the failure of cage. The cage failure can be occurred due to the crack and chips, flax and distortion, rust and corrosion, then wear, and the it can looseness and improper riveting. So these are the failures can be occur with the cage, and the reasons behind that, the crack and chips are occurred due to the um, careless handling, abnormal loading, and vibration impact. The flues and distortion can be occur because of careless handling. Rust and corrosion can be occur because of improper sealing capability. Periodic inspection of lubrication is not there. Then provision of additives, rust preventive during the storage of the bearing is not provided. About the wear, improper lubrication or the shortage of lubricant, which can investigating followed by the uh, countermeasure involving bearing and lubrication method. So because of improper lubrication, the wear can be occur. Then when foreign particles are in between the guideways or rolling ways, the wear can be occur. Looseness and cut off the rivet. The improper bearing mounting is the main reason where it can be reduce the bearing inclination, and because of that the looseness and the cutoff of rivet can be occurred. Again, because of the vibration and the other several loads where it is in contact, at that time the such failure can be occur. Okay, so in a figure, all the way all the phenomena are properly shown, you can see. So these are the modes of failure of the gears. So if you have any question, you can directly WhatsApp me.